going to get through this whole lesson in one class. We're going to get most of the way through, and I'll give you a few questions to try. But I also know that a lot of you are still wrestling with the last one, with lesson 6, and I get that. This first page here is a pretty good review of everything we've done so far with projectiles. We said when we launch an object into the air, we call it a projectile, and if we ignore air resistance, projectiles travel in a parabola. In fact, the math you learned in Math 11 last year about the parabola, especially finding the vertex, one way you could find the maximum height of a projectile is to turn it into a parabola and find the vertex by completing the square. That's a fairly lengthy way. We have more tools at our disposal because we've got some physics we can use, but that would work for what it's worth. First of all, we're going to break each projectile's velocity into vertical and horizontal components. On your test, probably for 2 marks, I'll be giving you a question somewhere where I ask you to find the components of something. Example 1 says, break the following velocity vector into its vertical and horizontal components. So this is a side view. It's being launched above the ground. So first thing I'm going to do is I'm going to go d. I'll call that Vx. I always do horizontal first. D. I'll call this Vy initial. Keaton, how come I put an initial on the Vy, but I didn't put an initial on the Vx? Well, here, even more, zoom back further than that. What's my vertical acceleration as a number exactly? What's Ay? What's my horizontal acceleration? Since there's no acceleration, there is no initial or final. It just is what it is. Here, it's changing, and I'll remind myself of that. Color, 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 color. Justin, that 24, opposite, adjacent, or hypotenuse. Vy, opposite or adjacent. Vx. Vx, which trig function? Yeah, it is h, so is correct. That's good. A and h, cosine. I agree. In fact, it's going to be cosine of 36 equals Vx over 24. How would I get the Vx by itself? Yeah. And I'll get 19. I'm going to carry some extra sig figs. 19.416. Which trig function is Vy going to be? Wait. You're right. Which trig function is Vy? Say it again. Not to make fun of you, but to make a point. Which trig function is Vy? Say it again. Lesson 6, when we looked at ground at an angle. Oh, which trig function was Vy? Mr. Dueck? Yes, Justin. For projectiles launched from the ground or up at an angle, will it always be Vy is sine and Vx is cos? As long as I give you the angle from the horizontal, which I will? Yes. So Evan, you ready for your dumb shortcut? If you're looking for a dumb shortcut for velocities, Vy will be sine, Vy will be sine. Justin, can you guess which trig function Vx will be? Of course you can. Of course you can. If you're looking for a cheap hack for memorization to save yourself some time out of laziness, so I'm still going to write sine 36 equals Vy over 24. But as I get good at this, Liam, I'm going to start to say, you know what? If you're giving me the side view of a velocity measured from the horizontal, Vy is going to be sine and Vx is going to be cos of cos it is. So it's going to be backspace and edit 14.107. I can't say this is free marks, Sophia. You need to know some trig and some physics, but I'm hoping it's close to free marks when I ask you to find the components of a velocity on the test. Type and away I go. This right here is a nice summary. For those of you that like to study from notes, this here is a pretty good page to put a star next to or to highlight. This is what we need to know about projectiles. The first thing is Vx is constant because Ax is 0. That means that dx equals vxt plus a half axt squared just becomes dx equals vxt. A is 0, Liam, so the half at squared vanishes. What this means is if you know the time of flight, you can find the horizontal distance, also called the range. Dx will be vxt. Oh, also though, if you know the range, you can find the time. Time is going to be dx over vx. In the homework, I'll give you a couple of questions where instead of giving you the cliff height, I'll give you the range. Way easier, Carson, because you don't even get a quadratic to solve. Way nicer. Vertically, there's a bit more to it. Vy changes because the acceleration is negative 9.8. The acceleration is constant, negative 9.8 meters per second squared, but that means your vertical velocity is changing. So dy will be Vy initial t plus a half Ay t squared. Sometimes Vy initial will be 0 horizontally from a cliff, but not always. Oh, at the top of its arc for a split second, Vy will be 0. Does this mean your overall velocity is 0? Don't write this down. If I launch from a cliff right there, Vy will be 0. Does this mean the overall velocity is 0? Why not? Yeah, it's still Vx. Really, what it means is V total just equals Vx at the top. That's a lovely trick question that you're going to see when you start working through the ultimate review. They'll often say, what's the velocity at the top? People will say 0. No, Vx, because that's all that's left. Also, if we start from the ground and end at the ground, because what goes up must come down, we can say that your final velocity, vertically, is equal to your initial velocity, but negative, vertically. Finally, if you're beginning from a vertical height from a cliff, your displacement will be negative. You're landing on the ground below from where you started, and so your displacement will be negative. They'll give you a height. You'll need to add the negative in front of it. Mr. Dueck, what, Carson? You said that projectiles travel in parabolas and parabolic paths, but I've occasionally thrown something and I've seen it kind of wobble, like when it's a warped basketball, for example. You know what? That's a good point. What really is traveling in a parabola is an object's center of mass. But for a warped basketball, the center of mass is not at the center. Put your pencils down, look up. Or another good example, instead of a warped basketball, if you've ever thrown a tennis racket or a badminton racket while spinning it, because the center of mass is not the center of the object, it'll look like it wobbles like that does. Or this one will wobble pretty good. And this disc will really wobble. It looks like it's wobbling in the air. That's because its center of mass is not at the center. We're going to do the same experiment, but this time we're going to have only the center of mass highlighted under an ultraviolet light. And you'll see no more wobble. The center of mass travels in a nice parabola. You really notice it with that wobbly disc that wobbled so much when it was spinning. So here's the center, not the center of mass. You're going to see it wobble. Here, this is where the center of mass is. That traveled like a nice projectile. So center of the object, lots of wobbling, because the center of mass was not at the center of the object. Center of mass, nice parabola. Projectiles from cliffs at angles. These are the hardest. There's going to be one on your test. There's three ways you can solve for time because you're going to spend most of your time finding everybody time. The first method, you can find the time to the top, and then starting from the top, find the time all the way to the ground, and then add them together. I'll give that a meh. Works. Meh. The second method is you do it all at once in one step. Yes, Mr. Dueck prefers that. If I can get there in one step, I'm going to get there in one step. Third method, I don't recommend. You can find the time to the top, double it. That would give you the time back down to the cliff height, and then continue on and find the time all the way down. Not recommended. Mr. Dueck prefers strategy 2. It's going to require you to solve a quadratic equation with the quadratic formula, unless you have the built-in quadratic solver. If you're really struggling with that, if you see me during a flex block, I can show you, I can walk you through strategy 1, the meh. And the only reason it's meh, it's extra lines, extra writing, and you've all had me enough to know lazy but organized, right? So I like example 1, I like example 1. Example 1 is a nice question. Yeah, through the page. So Bishon, what do we have here? We have a cliff, yes? And an angle? Okay. What does it want us to find? It's going to take us a bit. First of all, did I say angle? Before I go any further, although I can use a bit of a shortcut now, Vx equals Vy. Which trig function is Vy going to be? Sine, you say. So it's going to be 50 sine 30. In your homework, I would even be okay if you skipped writing that and went straight to your calculator. I'm putting it in our notes so that when you're studying Liam, you know what the heck we did. This one I think works out evenly. Check me, but I think it's 25 even, isn't it? Well, if Vy is sine, can you tell me which trig function Vx is going to be? Of course you can. It's going to be 50 cos 30. I got 43.301. I'm carrying extra sig figs because you'll notice the question asked me to find time, not the components. I want my time to be good to 3 sig figs, so I'll try and carry other stuff to about 5 sig figs. So 43.301. Okay. This is a projectile. Who remembers from last day, what was the hint, what was the tool that I said you wanted to work with? T-table. I'm going to do my T-table because I want to use this space. I'm going to do my T-table kind of over here. That lets me save some room. There's X, there's Y. Bishon, what are two no-brainers that I can write down for a projectile right away? AX equals, AY equals, and then the other two I'm going to drop down from my components. VX is 43.301. VY initial is 25. What else do I know from the picture? What number haven't I used yet? So what am I going to write for dy? Y negative, you're correct. It's a displacement. We are ending up below from where we started. Which column do I know 3 things in? Horizontal or vertical? Which column am I going to find time in? Vertical. So part A said find time of flight. I'm going to go t equals question mark. And Bishon, I'm looking for an equation that's got a t, an a vi, and a d in it. There is one. dy equals vy initial t plus 1/2 ay t squared. Are any of these zeros? A half at what? This is going to be a full quadratic. So I have to resort to not being able to get the t by itself because there's more than one t. Plugging in numbers. My quadratic equation is going to look like this. Negative 60 equals 25t minus 4.9 t squared. Liam, I was a little lazy. I went negative 9.8 divided by 2 in my head. That's where the minus 4.9 came from. What kind of an equation is this? Quadratic. How do I know? Because it has a squared. What was step 0 to solving a quadratic? Make it equal to 0. That's why I called it step 0. The least amount of work would be to plus the 60 over, but I know I make more dumb mistakes when the quadratic term is negative, so I'm actually going to plus the 4.9t squared over, and I'm going to minus the 25t over. When I do that, Evan, I get positive 4.9t squared. I get take away 25t, and then the negative 60 stayed on the left, so it drops down like a domino. Bishop, what's A? B? No. C? Now, those of you that have the built-in solvers, go. You'll be done in about 10 seconds. Those of us that don't, we need to solve a quadratic. Quadratic formula is on our formula sheet. It's going to be not x equals, t equals negative b, so negative negative 25 is positive 25, plus or minus the square root of negative 25 squared minus 4 times a times c all over 2a. You know what? 2a is 9.8. I don't have the fraction button, so I got to put the top in brackets. 25 plus the square root of 25. I know it's negative 25 squared, but a negative squared is a positive, so I'm going to be lazy and just not write the negative. Minus 4 times 4.9 times negative 60. Close off the square root. Close off the top. Divided by 9.8. Let me go looking for typos. I think I missed a times there. Minus 4 times 4.9. Do y'all get 6.8814? And then my other root, I get negative 1.779. Which of those answers do I not use? Yeah, we would go like this. In fact, the proper term is we reject the solution. Reject, like Keaton trying to dunk, reject. Right. Now, they wanted me to find time. Now, Bishop, I'll report my final answer to my usual 3 sig figs, and I'll include my units, and I'll even draw a box around. Hey, there's the answer time. Who's all has the quadratic solver in this class? So it's about 10 seconds or so for you guys to get those, yeah? It's pretty quick. See what happens when you listen to your teacher? If you still can't remember how to find it, how to do it? Oh, man. Or just use it so often that it becomes instinctive. We'll pause. Considerably more writing, but also, this is going to sound weird. I hope you didn't learn anything new here. Like, I hope, oh, I've done components before. Hey, I could have figured out the t-table. Hey, I would have clued in there's 3 things in the vertical column, so I'm going to find time vertically. Hey, I would have found that equation. I probably would have clued in, uh-oh, time doesn't count. I'm going to have to do a full quadratic. That's my hope. What else can I ask? B. B. Rashawn, what does B want me to find? Range, is that horizontal or vertical? Who remembers from last day? Yeah, range, this is a synonym for dx. In fact, if we go back to our t table for part B, what we're really saying is dx equals question mark. Uh-oh, I only know two things in this column. Or do I? What else can I put in this column, Gershon? Why? Time. Why? Because time is I'm looking for a word that starts with the letter S and rhymes with Kaler. Because it's a scalar, it can go in both. It has no direction, much like your future. It has no direction. So I can put the time value 8814, and now I have three things. So I would say, Gershon, I'm looking for an equation. It's got an A, a V, a D, and a T in it. There is one. If you haven't noticed, that's the one we seem to be using the most. Yes? Oh, but what's A? So we can just say dx equals vxt. Hey, do I know vx? I've scrolled down. What was vx? No, it was not. What was vx? Vx was in the 40s, wasn't it? And then time was 6.88. No, 6 point, was it 6.8814? That should give me a good answer to 3 sig figs. I get 297.9. You know what? I think 298 if I go to 3 sig figs. Yes, Khrushchev? Meters. Mr. Dueck. What, Jacob? Does that negative time, that negative 1.77, does that actually mean anything? It kind of does. Actually, it says this. Don't write this down. This is just for nerd trivia. Jacob, if instead of going up at a 30-degree angle, 50 meters per second, if you were going this way, down at a 30-degree angle at 50 meters per second, and if you could somehow go into the ground, it would take you 1.77 seconds to hit the ground, to hit ground level. That's how long you would have had to have traveled to hit this spot to continue on with your projectile. So it does have kind of an interesting meaning, but I'm okay. So the ground's there. It's moot. It doesn't matter. There's ground in the way. Gershon, that okay? Yeah, yeah, yeah. Kai, what does C want me to find? Top. Do you think that means vertical or horizontal? The word top. So I'm going to think vertically. I'm going to say, okay, this wants me to find T top equals question mark. I can still say Vy initial is 25. Can I say dy is negative 60? Was it negative 60? Why can't I say dy is negative 60? At the top, will my displacement be 60 meters below from where I start? No, 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 it's going to be something up. Okay. Um, oh, vertically, I can use ay equals that. I know one more thing vertically at the top for a split second. Vy final is 0. Kai, I'm looking for an equation that's got a T, a V initial, a V final, and an A in it. There is one. Yep. I think that one has a D in it, doesn't it? We heard it over here. VF equals VI plus AT. This is the one they learned first, and they probably memorized it last year out of laziness. It's kind of their familiar, I've used this one so much. Let's get the T by itself. So we're going to use VF equals VI plus AT, but we're going to say that T equals VF minus VI over A, but I'm going to remind myself vertical, vertical, vertical. I'll put Y's next to everything, make sure I pick the right values. You can see otherwise it might be easy to put the slanty one in here saying, well, that's the initial, isn't it? So it's going to be 0 minus, was it 25? Divided by negative 9.8. And I get 2.5510. I'll call it 2.55 seconds. How long would it take to get from the top back down to the ground? How can I figure that out? Yeah, 6.88 minus this will tell me how long it took to get from its maximum height all the way down to the ground. So there's lots of information with a bit of cleverness, Carson. You can figure all sorts of stuff out. D is very tricky, but I like it because we're going to be putting everything together for the whole unit. I don't know if I'm saying I like this question. Well, yeah, I am saying I like this question, like this question, like this question. I think I am. Sophia, what are they asking me to find? So the first thing I'm going to do is dulp. What's the impact velocity? Don't write this down, just watch for a second. I think it hit the ground like that. Or you know what? Maybe shallower. Or you know what? Maybe steeper. But I'm telling you, when it hit the ground, it was going downwards at an angle. So I'm going to draw kind of a sample impact velocity. I'm going to draw it fairly big. I'm going to say right there, that is the impact. It's hitting the ground at an angle. Did I say angle? I'm going to now say, I'm going to break this up into horizontal and vertical. Now you'll notice for vertical, I didn't put an initial, I put final, because that's the last velocity right when we hit the ground. Now, my drawing, Luke, might be bad. It could be steeper. It could be shallower. I usually just do about a 45-degree angle as kind of my template to figure out stuff. What's along the top one there? Say it again, you're right. Wait. That's the one that doesn't change. I know it. What's Vx? Go look at your chart. I'm going to say to you, 0 was a bad guess. You have it sitting right there. What is it? Yeah. Do I know Vy final? How fast it's traveling vertically when it hits the ground? Not 0. I'm sure I would have said something, Luke, about belly flopping off of your lab table onto some. It's going to hurt. So I don't know Vy final, but you know what? I can find it. I can say to myself, self, I'm going to do half a T table. I'm not going to do the whole thing because I don't care about the horizontal. So I'm just doing the right-hand side. I know AY, negative 9.8. What was Vy initial? That's 2 things. I need 3 things to find the fourth. What else can I use? Oh, yeah. I can use the time of 6.8814 seconds. I think that's what it was. I'm going from memory here. Yeah, that's how long it's been traveling when it hits its Vy final. Okay. Look, I'm looking for an equation that's got a Vf, a Vi, an A, and a T in it. There is one. Yeah, one we just used as a matter of fact, yes. Get the, oh, I was going to say get the VF by itself. Spoiler alert, already has! It's going to be Vy final equals Vy initial plus AT. So we're going to have this. Vy final equals 25 plus negative 9.8 times 6.8814. Luke, this is going to be stupid obvious. Don't overcomplicate it. What direction was this projectile traveling vertically when it hit the ground? How would I show down mathematically for a velocity? I'm expecting a negative on my calculator. If I don't get a negative on my calculator, I'll be nervous. I think you get a negative. Actually, what'd you get? 42 point, you know what, Mr. Duke, why don't you type it in? 25 plus negative 9.8. I think you carried a few extra sig figs than I did. Or were you clever enough just to type in the trig function and say, I can do that instead of writing out the velocity? Is that what you're doing? So some of my students clue in. It's up to you. They'll say, Mr. Dueck, writing 43.301, that's 43.301, that's 6 characters of writing. Writing 50 cos 30, that's only one extra character, and that's going to be not rounded off, bang on accurate. So I have some of my kids, they just write the trig functions instead of the actual value of the velocity. Oh, sure. So I expect you to be good to 2 sig figs, and on some questions, I will know that the numbers will work out that you're good to 3 sig figs. It really depends on how many calculations we're doing. There's going to be one in rocket science where one question, I swear to you, takes up an entire page. They're about 18 lines. It's rocket science. What were you expecting? Those ones, I generally, as long as you're good to 2 sig figs, and even the second sig fig, you almost always get an answer in scientific notation. If you were supposed to get 1.87 and you get 1.9, I'm good with that. But honestly, I'd probably still take 1.8, even though there's just so much rounding going along. But I'll try and show you some tricks when we get to those ones of here's how you can do it. Again, lazy but organized. I've really obsessed over it. So I was typing and I got distracted. Sorry. Negative 42.438. And I'm going to put that on my free body diagram, sorry, on my vector diagram, 42.438. There's my triangle. Mr. Dueck, yes, Bishon. Isn't the 42 supposed to be negative? Bishon, there's the negative right there. Isn't the arrow pointing down? Right? That's the negative. Here's the right angle. Which theta am I going to find? Where am I going to color? Top left or bottom right? Why? Top left is correct. Where the vector is coming from. So theta is going to go here. Color. Luke, coming back to you, how can I find the magnitude if I know the two sides? How can I find how long the hypotenuse is? I'm looking for something that starts with the letter P and rhymes with Pythagoras. Okay, so because we're brushing the cobwebs off a little bit, I'll write this out. I'm going to say the impact velocity squared is going to be 42.438 squared plus 43.401 squared. And then how to get rid of a squared square root. What do you get for the magnitude, Luke? I think you're going to get something in the 60s-ish. What'd you get, Luke? 60.6? 0.6 or 0.7? 0.6? I'd take either here. Meters per second. Are we done? No, we've just found the speed. They asked us to find the velocity, which means we don't just need a magnitude, we also need a magnitude and direction. So, color. Luke, Vy final, opposite, adjacent, or hypotenuse? What about Vx? Which trig function has the O and the A in it? So it's going to be tan theta equals 42.438. Still don't need the negative addition. I include that in my vector diagram. Divided by 43.301. Is that right? Opposite over adjacent? Sure. Now, I've got a bit of an advantage since Vx and Vy are nearly the same size. This is almost an isosceles right triangle. You're going to be really close to 45 degrees. Because if they were the same size, it'd be exactly 45 degrees. Let me do the trig, but I'm pretty sure that's what we're going to get. Shift tan of 42.438 divided by 43.301. Yeah, 44.4 degrees. Luke, is that what you got too? What of what? Well, if you said south of east, I wouldn't mark it wrong, but I would give you a little bit of a stink eye just because look up. That's not north. Up is not north, and down is not south. North is the back of my classroom. South is the front of my classroom. And so the way we describe this, because it's a side view that we're looking at, we would say below the horizontal. Liam, that's what we call it when it's on the way down and you give it an angle relative to the horizontal, an angle of depression. What if it was on the way up? I wouldn't say below the horizontal. What would I say? But when would it be on the way up? Oh, they might say after 2 seconds, what's the velocity? And you might still be on the way up when you're doing that. I don't know. Example 2. We'll finish the lesson just with this one. Ragav, what does example 2 want me to find? Okay. Do you see a cliff? Do you see an angle? Components. Horizontal, vertical. Ragav, what's AX? What's AY? Vy is which trig function? So let's be brave and see if we can go straight to Vy initial by going sine, you say? So what always goes inside the trig function? The angle 20. So it's going to be 35 sine 20. And I get 11.971. All right, if you were able to find Vy initial, which trig function is Vx? Do you know? Of course you do. And in fact, on my calculator, yay, I can just backspace and replace the sign with a cos. And I get 32.889. 32.889. What else is the question given me that I haven't used yet, Raghav? Oh, height. That sounded vertical to me, yes? They tell me that's a dy. What am I going to write? dy equals negative 20. What did they want me to find? Which is dx. Don't write this down, look up. For what it's worth, you would go dx equals question mark, but then you would say, how many things do I have in the left-hand column? 2. How many do I need? 3. Uh-oh. You know what? Even though it says find the range, anyone want to guess what we're going to spend most of our time finding? And I think we're going to do that vertically because that's the column I have 3 things in. So, A. T equals question mark. Raghav, I'm looking for an equation that's got a T, a D, an A, and a VI in it. Our old friend. Well, it's going to be the whole thing here. It's going to be D equals VIT plus 1/2 AT squared, and I would remind myself Y vertical, Y vertical, Y vertical to make sure I don't accidentally put a horizontal value into a vertical equation, or vice versa. Psst. It's going to be a quadratic. Let's plug in our numbers. We're going to get negative 20 equals 11.971 t minus 4.9 t squared. I'm pretty good at dividing the negative 9.8 by 2 or times it by a half, same diff. Raghav, what's step 0 in solving a quadratic? The phrase we're looking for is you have to make it equal 0. That's what we need to say. Because gotta move it, I can move stuff all over the place, but if it still doesn't equal 0, I haven't done that job. That's why I call it step 0, right? I'm going to, I think, plus this there, minus this there. I'm going to get positive 4.9 t squared, take away 11.971 t, and then take away 20. Negative 20 would just drop down like a domino. Now what? How do I solve that? What kind of an equation is this? How do I know? It's got squared and it's got, yeah. So have you got the solver on your calculator? Well, then use it. The rest of us, you and me, Liam, apparently we're the only ones slumming it. Okay. T equals negative 11 would be positive 11.971 plus or minus the square root of b squared negative 11.971. Liam, I wrote the negative, but I won't type it on my calculator because I know a negative squared is positive, so why waste my time? And then minus 4 times A times C. You'll notice this time I didn't label A, B, and C in my original equation. See if you can get better at this and if you don't need to do that step. All over 2A, which is going to be all over 9.8. Bracket 11.971 plus square root, Mr. Dueck. And another bracket. Oh, and I missed my squared in my formula. Well, I'm making typos. 11.971 squared minus 4 times 4.9 times negative 20. Close off the square root, close off the top, divided by 9.8. Plus square root of, I guess I can put a 1 in here, can't I? Ah! Shoot, I didn't want to, I lost it all. That's a pain. Start over, Mr. Dueck. Dumb. Bracket 11.971 plus square root bracket 11.971 squared minus 4 times 4.9 times negative 20, close off the square root, close off the top, divided by 9.8. Is it 3.5824? It is? Hey, 3.5824. And just to check, because sometimes there will be two roots and they're both positive, which means they're both legit. When would that happen? I saw Bishon looking at me with a look of horror on his face. It would happen in this situation if a projectile was launched from a cliff at an angle like that, and you asked when it was that high, it's going to be that high twice. So if you're finding time, you would actually get two positive roots. But just for consistent, let's find the negative root, Mr. Dueck. Negative 1.14. Reject. Carson, that's not what they asked me to find. What did this question ask? You asked me to find. I just found time. I wrote G equals. It should be T equals, Mr. Dueck. How can I use this to find dx? Dx equals Vx, not VIT. Because technically VI is the slanty one at an angle. Did I say angle? Components. We're not going to use it. After we've componentized it, we don't use it again. I've scrolled down. What was Vx? 32.889. And then T was 3.5824. $32.889 times 3.5824 is my mistake. You get 118 meters. If I gave you this question, I would probably make it worth 7 marks because there's a lot of work to be done here. I'd probably give you 1 mark for finding the horizontal component, 1 mark for finding the vertical component. I'd give you a half mark for saying AX is 0, a half mark for saying AY is 0. That's 3 marks out of 7 already. The moral is don't leave stuff blank, Luke. Okay? We're going to pause here.